Okay, hi everybody. We're going to go ahead and get started. Just a reminder, if you could mute whenever you're not talking, that's going to help a lot with the audio quality. And if suddenly I go offline, it's because of my cat who just walked across my keyboard and hitting the escape key, but I think I'm safe. Okay, I'm good. Anyways, we can get started with the agenda. It's pretty packed today. The first one is going to be testing. So let's go ahead and get an update from Dimitri on that and anyone else after him who wants to update on that.
Yeah, hello guys. I have the first results of the test execution via RPC on my local branch of CVP Ethereum client. I managed to execute all of the state tests within the 7 minutes. So that's the research update, and now I'm going through the painfully slow process of integrating all of my changes from my testing branch into CVP client. So we're discussing with the CVP team how to optimize those changes and what should be the RPC methods. So the current state of RPC methods that I used, they're still on the same link and retest repository. It's not final, so everyone welcome to discuss those. And then if someone could provide me a client which managed to execute those tests faster than 7 minutes, it would be great.
Great.
Yeah.
So you need a client that actually runs the new type of test you're saying?
Yeah. The issue is that test RPC methods, there's no consensus about those methods. So I'm still struggling with that one method of how to add a new account or as a transaction with secret key. So the discussion with Yochi was whether it should be a new testing method for executing a transaction with a secret key via RPC or registering a new account with a private key, which then could be used to sign those transactions. So maybe you could help me with this. I mean, right now, I wonder what's your opinion.
Does anyone have an opinion on that?
So the question sounds like this: which one is better, a new RPC method to register a new account with private key, or a new method which provides transaction and a private key to sign it?
What's wrong with send raw transaction? How come the signing can't happen offline?
Send raw transaction requires this account to be registered in a key store.
No, it doesn't. Send raw transaction sends in a pre-signed raw transaction that doesn't.
Pre-signed. So the transaction should be already signed, you mean?
Yeah, that's what I'm asking. If it like you're saying why, if I understand correctly, you're asking for a RPC method standardized to import an account by sending in a private key, but what's wrong with signing the transaction and sending it in over send raw transaction?
Yeah. Well, in this option, the tool which runs tests will have to implement math needed to sign the transaction. And well, I think signing should be done on the client side.
Are we talking about testing? Because
yeah.
Okay, I'm not sure I understand that logic, but maybe we can talk about this offline.
Yeah, okay.
Yeah, Dimitri, if you could summarize what you just talked about and put it in the All Core Devs channel, I think then we can respond better on there. Maybe some of the clients aren't prepared for an answer.
Okay, I will post a link to the discussion on my GitHub issue.
Yep, thank you so much, and definitely, yeah, post it in All Core Devs, and we'll talk about it next meeting as well. And were there any other updates from anybody else about testing? Okay. The next agenda topic is EIP 712. Add ETH-signed type data as a standard for machine verifiable and human readable type data signing with Ethereum keys. So we talked about this last meeting, and there was a lot of support for this. However, there was also some talk about making sure that everybody in the ecosystem was on board because a decision was made to not keep backwards compatibility. Today we have Remco on the call. Remco, if you want to give just a quick introduction and how you're related to this EIP so that you can better champion it.
Yeah, sure. Hi. So I took over the ownership of EIP 712 from Leonid, who originally proposed it. And since I've moved it a little bit, originally it was a way to communicate kind of the interpretation of the data to be signed to the user agent, such that the user would be presented with a more elaborate view and understanding of what is to be signed. As I was working on this problem, I realized that it quickly splits up in a number of problems that need to be addressed when it comes to signing arbitrary messages through user agents. Quickly in order, these would be hashing of arbitrary messages without collisions and any security issues, of course. Domain separation, when messages do naturally collide, but you still want to somehow make the signatures incompatible. Nonces, which is something that I don't think has been addressed in the discussion at all. And with that, I mean, how do you prevent replay attacks? So standard Ethereum transactions use nonces for that. The signed messages do not have that. Currently, we require every implementation to come up with their own solution to this, which might end up being the only viable solution, but it might also be something we can address in some standard way to prevent people from shooting themselves in the foot this way. And of course, the original issue of how do we present all of this in a user-friendly way, such that people who are relatively novice to cryptographic signing schemes can still use them securely and relatively trusted. Now, this is a lot for one standard, and I mostly narrowed this standard down to the scope of just defining a hashing mechanism that is able to hash messages into a bytes 32 in a safe way, such that developers can basically just hash any struct they want and know that they're safe. It also touches on the issue of domain separation. Yeah, and that's basically where my where EIP 712 is at the moment.
Okay, so it sounds like you're still getting feedback on the EIP. In addition, have you received other, at least since the last core dev call 2 weeks ago, have you seen other people or other groups coming on board with this and saying that they support this, maybe any hardware wallets or things like that?
I know that the original EIP 712 got some early uptake, maybe a little bit premature from MetaMask, among others. I think right now they are waiting for things to converge before they want to reinvest in implementing everything. And I know that Nick Johnson is quite active in the comment section.
Yeah, Nick, what's your take on this right now, unless it's just basically editing the EIP for technical properness?
So I was pretty skeptical of the original standard for signed tap data, with the original idea being, to enable UI display of this. But I recently reread the revised EIP, and I think it's moving in a good direction. I think it could be a really useful standard. I just did a review and left a bunch of technical comments, but in general, I think it's really promising.
Thank you.
Yeah. Go ahead.
I read through the comments. Indeed, I noticed some of these issues, and I will definitely address them. I hope you're generally on board with the direction I'm taking it. I know it's more complex than something like ABI encode, and yeah, I explained why I was led in that direction.
Yeah, no, and having reread the updated standard, I'm now on board with you. I see where you're going with it.
Thank you.
So, if I may have a question, I have not dived into the revised version, but I'm curious about, is this standard generalized enough to be kind of a top-level standard, or should there be some other form of top-level standard, something like EIP 191, and have this as a subgroup of that, or does this accommodate all use cases?
I made it really, really generic, and right now it supports things that are not even supported in Solidity at the moment. So it should be extremely future-proof in a way.
One of my suggestions in the recent review was to make it a subtype of 191, because then we can cover other data formats as well.
I think that's a good idea. I realized that right now the only differentiator between this standard and any other signing message that we might want to add, or hashing, encoding that we might want to add in the future, is just the 1 byte, the 0x19, I think, that I turned into a 0x1. We can have larger differentiators. It should not really matter.
Okay, great. So
Just so in a way, this is already then let's say compliant to EAP 191, right? If you have a version number.
It needs a slight tweak to be 191 compatible. We should take this offline on the PR discussion, though.
Yeah.
Cool. So it sounds like there is a lot of support for this. I think it does need to be polished up a little bit, in my opinion, just because there's still a few more discussion topics happening. And then if we can, as much as possible, get a feel for which developer tool companies and hardware wallets and other people who rely on this get on board. If we can get as much of them as possible, I think this can be something that is accepted, in my opinion. Obviously, the other EIP editors will have to chime in and stuff, but it seems like it has good momentum right now.
Can I ask one final question before we move
Sure.
on to the next subject? So right now the scope is limited to hashing arbitrary messages, and it touches a little bit on domain separation, but I don't think it fully addresses the problem of domain separation yet. That's an ongoing discussion. It does not touch on the issue of nonces and preventing replay attacks. Is this something that should be covered? Is this something that we want to postpone to a future EIP?
It sounds like you would want to put that in as early as possible. I mean, if it can cleanly go into the current EIP, that'd be my opinion. I haven't read it though, so I don't want to give an opinion without reading.
Well, it's a separate issue, but it is one that might affect how any signing standard at this particular lower level is implemented.
Anybody have a comment? Otherwise, we can take the comments to the EIPs and we can ask on there.
Yeah.
Okay, cool. In that case, thank you so much, Remco, for kind of giving us that overview and giving us an update on it, and I hope this goes forward.
Thank you.
So the next agenda topic is EIP 665, add a precompiled contract for the ED 25519 signature verification. That is by Tobias Oberstein, who joins us here today, or Oberstein, sorry, who joins us, and he's going to kind of explain just real quick what the summary and motivation is behind this EIP, and we can try to get a feel of if anyone can use this for any other use cases.
Yeah, hello, my name is Tobias, and I'm sorry my name is probably shown as okay.
Could you speak up or get closer to the microphone, please?
I'm sorry.
There we go.
Can you hear me? Because, yeah, so the desktop client didn't work for me, and I'm on mobile.
I can hear you great.
Anyway,
go ahead.
So I wanted to propose adding a precompile for this specific signature procedure that is a quite popular curve. I'm quite sure you guys know that. It's developed by Dan Bernstein, and a lot of projects and a lot of protocols are using it actually. So, for example, SSH, there's a possibility you use SSH keys using that crypto curve and or DNS based or DNS servers. And so the motivation is to bind actually Ethereum keys or Ethereum addresses to ED 25519 public keys, or to verify signatures signed by those keys, and to actually bind both identities, or an identity on Ethereum to an identity on a external system. So, and obviously it would be possible to program that in usual or in EVM bytecode, but it's too slow, too costly in gas. So the proposal is to add a precompile for that signature verification. And well, I think it's the proposal or motivation. It's straightforward, but I wanted to ask if there's what do you guys think about that? Is there do you see a use of that for that? So we could use it. I'm working for a project Crossbuy. We're using those keys, and we would like to bind those to Ethereum identities or addresses. There's motivation or verify signatures within smart.
Okay, sounds good. Does anyone have comments on that? Anybody who's looked it over or like browsed it? Oh, Vitalik and friends, I think I can hear you typing. If you could mute.
I only have a comment I can add a couple of anecdotes of companies that have requested this feature from Parity. So some just say that the BN precompile is too slow and that ED would maybe be faster. And like they're trying to do some on-chain crypto stuff and like either they want the ED curve specifically or they're just like trying to find a way to do it in as cheap a way as possible, and so the BN precompile is not what they're looking for.
Hold on. So the BN 128, alt BN 128 is not by itself like as a curve much slower to execute than like there's nothing inherently mathematical about the curve that makes it slower to execute than SecP, right? Like, as I understand, the only reason why the implementations have been slower than SecP so far is just because like there seem to be better and more optimized libraries for SecP than there are for alt BN 128. I mean, so
yeah, that's probably true. But like the Go implementation recently used the BN implementation from Cloudflare, which is now really fast on 64-bit platforms, but pretty slow on anything else. On Parity, we're like in the middle on all the platforms because we're not using assembly.
Right. So I guess one question is like, how much do we need to care about 32-bit platforms, given that a lot of machines, like most machines, are probably 64-bit already, and the ones like we've already made a decision to kind of not care that much about older hardware because of how difficult it is to run Ethereum on an HDD or even on anything with a low amount of memory. So like my instinct would be to just favor making more optimized or finding or potentially even like supporting and subsidizing more optimized implementations for the existing BN stuff, like if at all possible, right? Because that's just something that doesn't really require consensus work.
Yeah, I think that's fair enough. I don't know of any specific use case that requires the ED stuff. So
yeah. So I know that the ED stuff does have like real practical advantages because like it is at least like slightly more efficient to verify, and it has batch verification, and it has like good cryptographic properties because the signing process like doesn't have like branch conditions that make it easily vulnerable to side channels and so forth. But like, I guess, are those benefits large enough to be worth an entire new precompile? I'm inclined to say likely not. Like alt BN like have like for that curve that was enough because like it created the entire new capability of doing pairing based cryptography. But here the gains just seem more marginal.
Okay, do we have any other comments on that? My comment would be, in the past sorry about that cough. In the past we've talked about no longer putting in precompiles because EWASM is coming up, and I'm not sure if we're still of that opinion or not. Just because the time it would take to implement and test the new precompiles would take away from the time implementing stuff like Casper sharding and EWASM. And the fact that EWASM can sometimes run those curves natively is kind of what I remember people talking about. Is that accurate? Or can anyone correct me if it's not?
Yeah, so I've definitely, like, my understanding is definitely that EWASM is fast enough to just implement all the cryptography in EWASM. And I would be I personally would be willing to consider precompiles, but for cryptographic operations, but only if they really bring substantial added value. And at this point, we have hashes, we have signature algorithms, we have pairings, we have big-int arithmetic. I would say at this point, like, if we want to expend units of work on precompiles, then my preference would be to focus on both making AltPN 128 more efficient and just really cutting down the gas cost to make it viable, and seeing if we can cut down the gas cost of big-int arithmetic as well. Because I talked with the Zcoin people about a week ago when they were complaining about the gas costs for Zcoin verification just being like crazy high.
Okay, I see. So yeah, Tobias, did you have other comments on that? What it kind of sounds like is what we would need wider support for this to go in.
Why they use, for example, in DNS servers or SSH servers,
Tobias, if you're talking, you're very muted.
How would you verify, or how would you bind an identity on Ethereum to an external system that uses that AD curve?
At this point, you wouldn't. I guess would probably be the answer, unless someone has a better answer.
Just to interject, for my part, ED25519 would be quite useful for DNSSEC support in ENS, just as another use case.
Is it possible to somehow quantize that in like how much more use? Would it like enable 50% more DNS servers, or?
I've just grabbed the root zone for DNS and I'm doing some grepping over it now to give you some figures, but it'll take a few minutes.
Okay, so I think this is something we need to explore a little bit more to see the usefulness. So do we want to just come back to this topic later in the call?
Yeah, on a side note, Vitalik mentioned lowering gas costs for arithmetic operations and for precompiles, and I think that's a good idea. Some measurements show that, I mean, the basic operations can probably be cheaper than they are already with some dedicated libraries and optimizations, at least for the Go client. And I think we all know that it's basically the disk accesses that take the most of the time and needs to have a heavy gas cost, whereas the arithmetics could probably be a bit cheaper. So that's something we should benchmark a bit more and discuss if we should change the gas costs again.
Okay, sounds good. Tobias, does someone have a comment?
I can just say that I can try to reach out to the people that asked for the ED25519 curve and ask them to put in their specific use case on the EIP, and then it can be there for consideration.
That's a really good idea. Tobias, does it sound all right if we just start to kind of collect more use cases and add them to the EIP?
Yeah, that sounds perfect. Great. Thank you.
All right, thank you very much. All right, getting on to the next agenda topic, we have modify block mining to be ASIC resistant. That's something that Piper initially started and has now grown into a large topic of discussion in the community. So Piper, if you can just give a quick background on how that EIP started and where it is now.
Yeah, I can do that. So just as a disclaimer up front, I decided to just sort of facilitate this discussion. This is not an area where I have the expertise to be making decisions, so I am acting more as a facilitator. We've got an EAP that was merged as a draft a few days ago that proposes some very low-touch changes to the ETH algorithm, things that if I understand correctly, should be very easy for clients to modify their internal block ceiling to accommodate these without any really significant changes. The idea behind this is not to improve ASIC resistance as much as to an attempt to break existing hardware. And at least from my perspective, that approach is intended to be a short-term fix to push the assuming you agree that ASICs are a problem or that we don't want them on the network, the hope is to push them out far enough that we have time to get proof of stake into place. That also works under the assumption that proof of stake is still far enough out that ASICs coming onto the network and being on the network now will be a problem. So anyways, that's the high level description of the EAP that's currently in process or underway. I know that there is a very easy path for us to take, which is do nothing. And I'm not convinced either way that we should do something to break them, or that we should sit back and just keep focusing on the things that will permanently fix this. And part of that is just not knowing very clearly what the timeline is likely to be on proof of stake being sufficiently far enough along to actually fix this. So mostly I'm hoping for people with more expertise and more knowledge to chime into the discussion so that we can actually come to some form of consensus on this.
So I'll probably repeat the comments that I made in the Gitter, which is that, like, first of all, well, there is one thing that so first of all,
sorry, Vitalik, I want to throw one more thing in. I have had one piece of back channel communication that indicates that we can expect these to not be programmable, the current ASICs that are in production. There's no way to verify that information, and so you can take that as you will. But I just wanted to toss that one more thing in there.
Okay. Yeah. So what I said in the Gitter is basically that, like, first of all, at least if you look at the E3, the one that got released a couple of days ago, the efficiency gains are relatively small compared to existing GPUs. So for my Chinese sources, like currently a 220 mega hash miner costs about $2,500, but the thing that Bitmain is offering is 180 mega hashes for $800, which is only a 2.5x factor improvement, and that basically doesn't that. Plus the fact that I know that when we were building ETH hash, we did an analysis and we basically showed that the algorithm actually does succeed at being IO bound rather than compute bound, which basically means that even if you may replace the computing with, like super fancy P-equals and P-quantum magic, it would still, the speed increase would still be limited because it would have to, the bottleneck would be RAM. Well, at least up to some point, right? Like if the computing module was extremely fast, then it could just do the live verification process. But I don't think they're even close to doing that. So those things together basically imply that at least that it seems likely that the ASIC is just like a regular computer with a better piece of RAM with anything non-essential that's in the GPU or that's in the RAM stripped out. And the other thing is that I heard, something about basically these ASICs using some new kind of RAM, either GDDR3 or something that's otherwise fairly hard to get. So that would imply that it is just basically a better a computer that's optimized toward IO hard proof of work algorithms. In which case, the immediate concern is basically that like there is nothing that we can do. And because like even if we just replace some ETH hash entirely with like Equihash or whatever the hell like the hell Monero uses or something similar, then it would like basically the ASIC would still just be able to do it. And it may be the case that that's not true, but we just have no idea, like, at least right now, what specific protocol changes actually would manage to make a difference. And like, given that, like, the only thing that I think would reliably stop these particular ASICs is switching the proof of work to something that's just not even IO bound at all. So one example that I brought up is just switching it to SHA-3. But like with a change that drastic, I'd be inclined not to do it because, like, first of all, if we switch to something like that, then that's less ASIC resistant, which would mean that we do ASICs for it again in something like 6 to 12 months. So we're only buying a bit of time. And also the actual development effort of making good GPU miners for SHA-3 and just getting everyone to upgrade is likely to be fairly chaotic and really detract from more important things. So at this point, I personally do lean quite significantly toward no action. I mean, the other reason to lean toward no action is that if you just look at a worst case scenario, worst case scenario is basically that, like, Bitmain controls like a very large portion of the Ethereum network for some period of time, and like the day they end up trying, like, like, this is not Bitcoin, right? Like, miners are not in control here. If there comes a day when they have like majority hash power and they try to use it for evil, then the net basically will just speed up Casper development and like to hell with any remaining bugs and just and try really hard to launch the thing within a week, and mining rewards will go down by 90%. So that's like, I just don't really see a kind of game for them that doesn't consist of just like acting in ways where they can make sure that it doesn't, that like only plausibly reveals that they have something like 20 to 25% of Ethereum hash power.
Do you? I feel like I've asked this question before, and but what do you feel like the timeline would be for us to be able to get a version of Casper in place that would?
So Danny is in progress of like finalizing the code for like the second stage of the testnet, and it's once and one of our goals for the second stage of the testnet is an algorithm freeze and like full specification of the algorithm. So that's something that like is totally ready for Geth and Parity to theoretically start implementing. Now, it is in progress of also being formally verified and also being like checked by multiple groups of academics. But if we really want to, like if 51% attack concerns demand it, then we can just totally skip all of the auditing and verification stages, right? So like basically, if Geth and Parity start make it higher priority to start implementing Casper FFG, then even that by itself gives us some amount of insurance.
Okay. And formal verification of that is something like 6 months out, or at least the timeline for that is 6 months. So
the runtime verification grant, I think they have like 5.5 months budgeted, or no, 4.5 months budgeted, and they started halfway through March. And they're making like really solid progress daily and working really closely with Yoichi. And they actually, well, yeah, that's. Can I go ahead and just give an update on what's going on with Casper, because we were already touching on that, and I wanted to share that.
Yeah, that'd be great, Danny. Go right ahead.
Cool. So as y'all know, the runtime verification guys received a grant and are doing formal verification of the Casper contract. Yoichi is working really close with them. I re-released the implementation guide last week with some of the updates we had made, and contacted some of the clients I think we jumped the gun a little bit of that because it's actually a little bit underspecified in terms of the fork mechanics. So we're working on actually writing the formal EIP that specifies exactly what the clients need to do at fork. We're finalizing some of the smaller implementation details, and I expect to have the EIP ready for review next week. So, I mean, generally the plan is have the runtime verification people formally verify, relaunch the testnet with the EIP specification so that clients have something to test against, finalize the Casper contract, fixing anything that comes up with the testnet and formal analysis, set block numbers for major release on the testnet and mainnet. Generally, a few questions I have is, where do C++ tests come into this, the yellow paper and KVM? In terms of like, does that stuff happen? I mean, C++ stuff needs to start happening when there's an EIP written, and then is the yellow paper and K formal specifications, are those updated prior to the fork or what?
Also, Chishan here. I'm working on implementing Casper on PyEVM. And I'll write up. Hi, Danny. I'll write up the issue, and that is everything we need to do, and work with GitHub and Viper on PyEVM.
Okay, great. Thanks for the update. To answer a few of your questions, Danny, what generally happens is there's an EIP that gives the motivation, abstract, specification, and implementation details. And after that is produced, then the KEVM team and the Yellow Paper team generally take that EIP and then translate it into pull requests towards the Yellow Paper and KEVM in order to keep up with the EIP as it's being developed. That's my understanding. Nick, I think we've talked about this a little before. Is that how you understand it as well?
Yes, I think that's a reasonable assumption. I'd clarify, though, that it's the editor's job is to keep the process moving, not to actually write the EIPs.
Yep, I agree. And then as far as testing goes, Dimitri, do you have an opinion on when something like Casper should start discussing with the testing team what tests to make?
I'm currently too focused on those tests via RPC stuff. Well.
Okay, then it sounds like we can
I'll
wait
check
till
back in with you when the EIP is being more formalized, Dimitri.
What time's the release is planned?
For Casper?
Yeah. And how many new EIPs approved?
The Casper EIP is going to be one EIP. Whether it's chosen to lump anything else in that fork, that decision's beyond me. I'd imagine it might just be Casper.
Yeah, so usually how these things go down testing-wise, sometimes tests are prepared well before the announcement of a hard fork, but they get shored up as we're announcing dates and stuff and giving timelines. So for instance, during Metropolis, we had tests developed, over the past 6 months because we knew what EIPs were going in, and just as the case with, Byzantium is what I meant. We have Metropolis coming up. Byzantium, with that instance, we had test cases made, and does someone have a comment?
If you want to implement a new test via RPC, it will require at least a couple of major clients to support it, and I still haven't finished the protocol itself. So if you really need to start the test for the Casper already, I think it's reasonable to work on the old formats that we have working with Hive and with test it and CVP client. So we just implement Casper changes in CVP as we did for Metropolis and prepare all of the tests in the same format that we already have tested working, and everybody seems to be fine with this format. And I just freeze my current work with the RPC methods and focus on a Casper test then.
Okay, well, I'd say continue your work until we until we formalize the ERP, and then we can shift if we need to.
Yeah, and maybe I will be able to finish this new test format in time before the Casper. Maybe there's just a couple of RPC methods to be implemented, and then every client should be able to work with the new tests. And I was thinking the last 10 minutes about this, and I think I'm going to do kind of a new test format, a general format for the Ethereum test, because I see that state tests and blockchain tests now have such lot things that are common, because the transaction being sent to the client and stuff. I think it's reasonable to develop a new general format for the Ethereum test, like no shenanigans with the state, blockchain, and VM kind of different tests, just a single test format for all of the possible tests that we could come up for Ethereum. And it should be executable via RPC. It sounds interesting.
Okay, great. Sounds like we're assured up there. And I want to make note that we're trying to coordinate here between the testing and the client implementations and the Casper research, but we shouldn't be rushing any of the research efforts unless absolutely necessary in worst case scenarios, since we like things to be very, very assured to not break and not have any issues as much as possible. So I think we can continue to do a good job of that.
Hudson, it's Ben Edgington from the Pegasus team.
Yes.
Just a quick one, coming back to your yellow paper remark earlier. So I raised a few months ago the idea that EIPs ought to contain a pull request to the yellow paper before they are merged or accepted. And I just wonder if that's relevant here. I don't want to derail the discussion, but just wonder if that had been thought about, or whether others feel that's a good idea. It needn't be written by the author of the EIP. There are others who can help with that, but it would help, I think, with the rigor of formulating EIPs.
Yeah, I think that's a great idea, and yeah, we had brought it up multiple meetings ago, and I think we should continue to discuss it. So yeah, that sounds like a good idea. We probably won't discuss it today, like you mentioned, but let's bring it up at least next meeting at the latest.
Cool, thanks.
Awesome. Okay, so as far as going back to the original topic of the ASIC resistance, is there anyone else who has a strong opinion that they want to discuss about whether or not we should implement something like that?
I think the proposed changes in that EIP are relatively straightforward, but I don't think the current situation justifies a fork on its own. I think we should consider rolling it into a future hard fork.
Yeah, definitely agree on that. Like this, I definitely don't think that even if we want to hard fork that ASICs are it's any kind of emergency situation that deserves even bringing things ahead of schedule, or bringing an immediate hard fork ahead of schedule.
That also probably lets us know that we're breaking something, as opposed to just probabilistically breaking it at that point.
Yeah.
Okay. Anyone else have a very strong opinion they want to discuss? So my take on this from a community perspective, I've been seeing a lot of discussion back and forth, and it kind of comes down to the people who feel that it actually is a security risk, but they're not entirely sure how. People who think we should do nothing, and then people who are very emotional about Bitmain and just are down with Bitmain, down with ASICs, stuff like that. I don't know where that comes from. I think it's like a crossover from the Bitcoin community or something. But yeah, so that's kind of what I've been seeing so far. And for those listening in who really have a strong opinion on this, who aren't core developers, you can do a carbon vote, and you can do an EIP on your own or do stuff in the forums and Reddit to kind of raise the issue more. Because if the community truly wants this to happen and has a good enough reason, I mean, we could definitely do that. But for right now, it sounds like the consensus of the core developers is that we should not do anything at this time, is what I'm picking up on.
Can we actually elevate the question one meta level up and agree on the conditions? What would be, like, what kind of development would require an emergency response? So what would be the conditions for this to be a problem?
That's a good point. Does anyone have any comments?
So what was the question? What would an emergency response look like?
No,
Or...
what would be the conditions?
No. So what would be the condition? So now we said that we should do nothing.
What would be the condition? Okay.
Basically, the only explanation for that was your assessment that these particular ASICs, which are probably just 2.5 times more 2.5 times cheaper per hashing speed, are probably not that much of an issue. But I think an interesting and important question would be, like, what kind of development would require an emergency response? So in what case we would say that there is a need for urgent action, which is not actually the case now.
So one thing to keep in mind, right, is that any ASIC manufacturer has an incentive to downplay the amount of influence that they have over the network, because they know that the more influence they have over the network, the more political pressure there is going to be to hard fork them away. So it seems to me extremely likely that even if Bitmain or whoever else, like what F2 Pool, like some, like the North Korean government, like some people in Iceland, whoever, even if they have 51%, the chance that we will find out before they actually start doing a 51% attack is quite low. So it's so because of that, like I don't think that we are going to see flags that are kind of redder than actually seeing an ASIC and being able to buy, and like someone being able to buy it, but less red than an actual 51% attack already happening. And so, like, it seems to me that like just seeing someone buy having someone buy an ASIC and being able to see it is not a sufficient condition, and a 51% attack actually happening clearly is a sufficient condition. And I don't really see anything in between, likely in between, that could be used as a flag.
There are signals we can look for, such as somebody promising to sell an ASIC that is orders of magnitude more efficient than the GPU, or a sudden uptick in proportion of mining power owned by one particular pool we suspect to be engaging in ASIC mining.
Mm-hmm.
So one question is, should we try to prepare by defining an alternate hashing algorithm and implement that and have it ready to go into a hard fork on a shorter notice than if we don't do that work?
My personal kind of intuition is that if we can just kind of farm it off to someone to make a GPU version of just simple SHA-3, then that could be or I mean, maybe not simple SHA. I mean, it might not be SHA-3, but just like any hash algorithm, then that would probably make the most sense, because like it's not IO bound and it's like very different. And for the time during which that algorithm is there, like it would still be, it would confer the kind of temporary benefit of making block headers much faster to sync. But like, ideally make sure to find ways to do that in parallel with all of our other work, so it doesn't like slow down client optimizations or like DOS resistance or whatever.
I think that I have what I need to go back to the EAP and sort of post a follow-up. If anybody else wants to toss anything in, feel free, but otherwise I think we've got a decent picture of how everybody feels about this issue.
Yep, that sounds about right. Daniel, did your question get answered sufficiently?
Yes, thank you.
Okay, thank you.
I have one more question.
Go right ahead.
What, say we have FFG on top of a mined network of that has ASICs. Do we consider this a problem?
For like security of the network, you mean?
Yes.
I'm not sure. So, oh yeah, Danny, if you could repeat the question real quick.
If we have a hybrid network where we have FFG on top of a network where ASICs have now kind of taken the majority of mining, do we consider that a problem?
So, okay, in that case, like as the protocol currently exists, what would happen is basically that a 51% attack can effectively prevent the finalization of new blocks, but it cannot cause a it cannot break finality. One simple fix that could probably like seriously mitigate the power of a 51% attack there is if we just add a consensus rule or if we add to the fork choice rule that a head it should be preferred if it has a larger number of Casper votes for the current epoch included inside of it. Right. So what that would do is that would basically say that if there is if there's an attacking mining chain that refuses to include votes, and then there's a good guy mining chain that doesn't include votes, then the fork choice algorithm will just favor the good guy chain. And that should render attack, even 51% miner attacks, relatively weak. Maybe that's Danny and worth kind of in the background thinking about and making sure that that works and doesn't introduce problems.
Gotcha.
Okay, cool. So we'll have Piper go back to the EIP. I'm sure community discussion will continue for a bit, and if it's still a really loud topic of conversation or things change, we can bring it up next meeting. Any other comments? Okay. The next topic is Vitalik's April Fool's joke to cap the total ether supply at 120 million, and then everyone took it seriously, and so let's talk about it. Who wants to do this? Or actually, Vitalik, if you want to start, could you kind of explain what happened as far as that 960 goes for those who aren't familiar?
So what the EAP basically does is it says that we decide on some maximum ether supply cap, and I recommended 120.4 million. And it basically makes all rewards inside of Ethereum. So this would be current proof of work rewards, and also it includes a commitment to make all future rewards, including like Casper voting rewards, like sharding block rewards, and anything like that, all be proportional to basically the maximum supply minus the current supply. And so that basically means that the ETH supply, instead of just going up linearly, would kind of exponentially, the growth would exponentially decay, and the supply would kind of exponentially converge toward the maximal. At least until we introduce things like rent and partial fee reclaiming, at which point we'll have a kind of balance where the supply will probably end up being constant at some level below the max, and coins getting burned and coins getting created would roughly match each other.
Oh, but that raises the question that for now, smart contracts have been pretty diverse in their way of burning Ether when they wanted to. For example, they just locked it up somewhere inaccessible. But if you have a limited supply, that would mean that there would be a formal way of burning Ether that would actually remove it from the calculated supply, like sending to address zero or some such.
Mm-hmm. Yeah, and there are different ways of doing that. So, for example, one way of burning supply that exists in the Casper contract is that if in the Casper contract, if a validator gets slashed, then their penalty is basically just stay inside the Casper contract as part of the Casper contract balance. And so in that case, it would be pretty, like if the Casper contract was the only thing issuing rewards, then it would be pretty easy to calculate because the Casper contract could just be assigned, like 20 million ETH, and then it would set any rewards to be proportional to like 20 million, the balance remaining inside of the contract. If we want to do something more standardized, then we could just do it based on, like you burn ETH by sending it to the 0 address. And then rewards like could potentially even be paid out of the 0 address and proportional to the amount of money in the 0 address. Or,
For my part, I personally think capping supply is a bad idea because you can measure, you can fund security either through inflation or through transaction fees. And funding through transaction fees encourages holding and discourages an active ecosystem, which I think is both a bad idea in general and also can lead to a sort of a deflationary spiral where costs go up because transactions are fewer and that leads to fewer transactions and so forth.
So it's really worth noting, right, that like the transaction costs in Ethereum are in the long run not proportional to Ether fees, right? They're proportional to supply and demand. And so like in general, it seems like they go up when ETH goes up because when ETH goes up, like demand and adoption goes up. But really, if the price of ETH were to go up for some exogenous reason, then which would happen if which in general is likely to happen if any kind of proposal is implemented that reduces the expected supply, then that increases the price without increasing adoption, and so it is quite likely that it'll just lead to reductions in the transaction fee that people actually pay. So like I don't see a reason to expect in the long run for there to be a kind of a hard linking there. Another thing is about deflationary spirals from the point of view of like macroeconomics. That stuff tends to apply much more when, like, first of all, the thing that is deflationary is the unit of accounts for an entire economy, and second, when like it's something deflationary that kind of a long-term sticky prices are being set in. And I think that like in the past it was definitely the case that Ether gas prices are sticky, but now like we have dynamic fee calculation for pretty much everything, and so I don't really expect Ether prices themselves to be sticky, and like ETH is hyper volatile to begin with, so I don't actually expect we'll even be able to notice the difference in like price movements as a result of any.
Right. I didn't mean deflationary spiral necessarily in the traditional economic sense, but in the sense that if we assume people adjust their behavior based on how much transaction is going to cost, and if we assume that there's some minimum amount of fees that we have to pay in order to secure the network, then high transaction costs could lead to fewer transactions, which leads to higher transaction costs.
So notice that like I'm not necessarily suggesting higher transaction costs, right? Like, well, okay. So I'm suggesting, well, first of all, like the main place that in the long run the kind of the money would come from in this change is from a lower revenue paid to participants who provide security. So in the short term, miners, and like in the long term, Casper validators, right? Like in the long term, I do think that Casper validator revenue should be roughly equal to the amount that people pay in transaction fees.
There's no closed loop there though, is there? Because presumably there is some level of incentivization we need, or some level of staking we need to secure the network effectively, and there's nothing that ensures that transaction fees will match up to that.
There's no minimum. There's like a level, right? Like. So, like, basically, if we have a smaller reward, then, like, instead of, like, 20 million ETH staking, we might end up having 10 million ETH staking, which on the other hand, though, like there is a risk that like if we have a cryptocurrency which is inflationary, then that could lead to its value dropping, which by itself leads to a less capital securing the network. So like it is kind of hard to like figure all this out in the long run. But I don't know, like I personally do think that there's evidence that the like in that basically like transaction fee levels are capable of providing enough revenue to secure a blockchain, and in the long run, if they're not, then like there's the question of, well, how valuable is the system? Like, is the system that we're building in the first place?
I mean, personally, I don't think that transaction fees have to be the thing that supports the blockchain. You know, if we need some amount X ether per day of money to incentivize miners or stakers, you can take that from inflation or fees. And personally, I think it makes for a more useful system if you take it from inflation, because it imposes the cost on everyone who is invested in the system, not just those who are transacting. And it encourages transacting.
Right. So I used to think this way, but the problem is that, like, as Vlad keeps pointing out, right, that if you do that, then like basically every ERC20 token becomes a better store of value than ETH. Like, if ETH becomes this unique token inside of Ethereum that has the anti-privilege of being inflated to pay for security expenditure, and you have the ability to just like print out ERC20s on top of Ethereum and like market them, and these tokens don't have this disadvantage, then like it may well be the case that like eventually there's going to be this tragedy of the commons, where even though ETH is necessary for network security, no one wants to support ETH.
That seems a bit of a stretch for like 2% a year inflation to me.
2% a year inflation is a lot. It's like the difference between like, so think of it this way, right? Like I believe it's the case in that like in the long run, people expect to be able to earn something like 4% a year returns reliably from the stock market. And if you take 2% off of that, then what you're basically saying is that the amount of money someone needs to retire goes up by a factor of 2, because you go down from 4% to 2%. So, like in the context of like financial market returns, 2% is a huge deal.
Okay, so do other people have any comments on what Nick and Vitalik are talking about? Yeah, it sounds like, let's see. Yeah, it sounds like we can bring this back to the EIP, I guess. Does anyone have an idea of community sentiment? Because I haven't been able to pick up on that as much.
From what I've been able to see, it seems broadly in favor of supply cap.
Yeah, that's what it seemed like on the EIP and in Twitter and Reddit, but those are only 3 metrics. So,
is there any point in discussing technical constraints? Because we currently have no consensus value for total issued ether, for instance.
That's a good point. What would it require on a technical level?
So my personal preference for implementation is that we just basically pre-mine like max cap minus current ETH supply into some particular address. And, this could be address 0. And we just basically say that whenever we're paying rewards, we subtract the balance from that amount, from that account. And then that account's remaining balance is basically by itself just used as the constant multiplying factor.
That's roughly 3 orders of magnitude simpler than what I was thinking. So sounds good.
It is it adds complexity to the Casper, the FFG contract, to have to calculate what percentage is coming from reward versus the base, but that's not actually that complex. So
okay, cool. So it sounds like there's actually a good amount of support around this. This would require a hard fork, so would this be something that could potentially be in Metropolis?
So, like, I personally see two possibilities. One of them is, like, if the community really wants it, then in, like, phase 2 of Metropolis. The other possibility is to just wait a bit and incorporate it as part of the Casper FFG change.
Yeah, and that'll depend on if we have Constantinople before Casper FFG, even.
Mm-hmm. Agreed.
Would that be a separate? That'd be a separate EIP. That would just be in tandem with FFG.
Yeah. Someone would have to champion that, and because I know Vitalik wrote, or Vitalik, are you actually currently championing that, or are you kind of waiting for what everyone else wants to do and someone else to write an EIP?
I'm kind of waiting on, I guess, like waiting to see more community feedback. Like,
okay, sounds good. Well, let's scrap this for now and bring it up next week. Once we have a little bit more feedback from the community post meeting. Okay, so the next agenda topic is EIP process updates. We'll go through that real quick. Basically, Nick made a really badass site called eips.ethereum.org that is automatically generated using Jekyll. Nick, do you want to kind of just go over that real quick, and also your automated bot?
Sure. I think I gave a brief overview of the site at the last all hands, but the basic idea is that it takes all of the markdown files for the EAPs and automatically indexes them by type and category and generates individual pages for them. So as soon as a new EAP is submitted to the repository, it gets updated on the site with GitHub's automatic page builds. I've also written, with the help of Makoto, a continuous build using Travis that checks EAPs and the repository and the PRs for syntactic validity. So we can take some of the load off the editors and make sure that everything's valid. That found a bunch of issues with the existing ones that have to be fixed, of course. Anytime you don't have a build, something slips through. And in general, I'm trying to work towards a setup where editors merge drafts sooner and quicker, and then make it easier for authors of drafts to continue working on changes until they're ready to take it to all core devs or ask it to be standardized if it's not a core EAP. So with that in mind, I've also written a bot that keeps an eye on EAP PRs, and when it sees one that is consists only of edits to existing EIP drafts, it will allow it to be merged if the author of the draft or one of the authors of the draft submitted it, or if one of the authors of the draft approved it using a pull request review. So that means that for trivial changes or changes to drafts, they no longer require manual approval by an editor. They can be automatically approved. And so any further suggestions on streamlining the process are welcome. I really want to get it to the point where open PRs all require action either from the submitter or from an editor, rather than the current situation where drafts can sit open indefinitely. And also to get it to the point where a draft submitter can get a permanent URI for their EAP almost immediately. And that's it from me.
Thanks, Nick. I also wanted to point out that there is a pull request 956 that Nick made to kind of clear up the draft process. So if anyone wants to give feedback on that, it's basically making the EIP1 less ambiguous with how drafts are handled, and it's getting a good amount of support, except for from some people who think that they don't want to take out the words "not keeping with the Ethereum philosophy." So that's one of the points of contention. So anyone who wants to chime in there, feel free to join.
With bringing up the other issue is a debate between myself and Greg Colvin about whether we should number EAP drafts immediately or only when they progress past the draft stage. I wrote the bot with the idea of either working with either system. But feedback on that appreciated. For anyone who wants to insist on keeping with the Ethereum philosophy bit, I would invite them to submit a description of the Ethereum philosophy that they can get 100% approval on. And if they can do that, I'll happily include it.
Yeah. Okay, cool. Anybody have comments? Okay, the next item is research updates. We've already heard from Danny about some of the Casper updates. Vitalik, you have Vitalik and friends. Who are your friends in the room with you again?
Zhicheng, Xiaowei, and Carl.
Cool. So is there any other research updates worth mentioning, Vitalik and friends or Danny?
I guess on the sharding side, we've been just looking at like more ways to make the like the entire setup of like how of how collations work and how collations get verified. It's like somewhat more efficient and simpler to implement in a bunch of ways. But like so far, it's still like ideas and formation. I mean, I expect the implementation algorithm to end up becoming simpler after the end of all of it.
Cool. So just to give a quick research update, Prismatic Labs has started recording their meetings, and they've also been releasing blogs on their updates. They're the ones who are trying to incorporate sharding into Geth. So anyone interested can look that up. And then James Ray 1 from GitHub is doing Drops of Diamond, which is a Rust implementation of Casper, I believe. And he's working on the SMC in Viper right now, and someone else is working on the Proposer and Collator to interface with
Drops
the SMC.
of Diamond is a sharding implementation.
Oh, sorry, you're right. It is sharding. Thanks. Yeah, so he's working on the SMC in Viper, and then after that he'll do it in Rust. So I don't know. That's beyond my knowledge, but that's what he's doing. I think that's it for research. Did I miss anything?
Yeah, just to add Pegasus to your list of people working on sharding, we put
awesome.
up a critique today on the ETH Research site of the current proposal around proposers and collators. Vitalik says it's all changed. We're waiting with eagerly to find out what the new model looks like. So yeah, that would be great.
Thanks, Ben. Okay, so if that's it for research, the next item is Metropolis. It sounds like we have some more things that could be EIPs, especially if we do that Ether supply cap. And if we were to do that before Casper, we could include some of the other smaller EIPs we've been wanting to include. So that's a possibility now. Does anyone have any other opinions after last meeting, thinking about it, about when Metropolis should be, or the second part of Metropolis, Constantinople, should be, or if it should even happen before Casper? Cool. Yeah, I didn't really have that much of an updated opinion either, except to say that the community is kind of, some of them are seemingly upset that we kind of implied that Constantinople would be done by now, but that it's not, and so they see that as us getting behind or not implementing things fast enough, when in reality it's just a separation and basically separating concerns and making sure other things are priority, including some of the research topics, implementations. So, anyone have any comments on that?
Right. Casper and sharding are probably the most important things to be working on in terms of forks to get ready, and those seem like they could be their own forks rather than part of Metropolis. So I think we are working on the most important stuff to be working on right now.
We could actually cancel Metropolis if we, or not Metropolis, Constantinople if we wanted to. There were some EAPs that we wanted to get in though, so maybe those could get in during the Casper fork. I don't think that would be too difficult to kind of bundle them all together. Any thoughts on that, anybody? Okay, cool. Well, I'll put it on the agenda for next time, and we can bring it up again, because there's not like a super rush on it or anything to bring up Constantinople, since no one has a strong opinion either way. Okay, we're going to zoom through client updates now. Let me start with Geth. Is anyone here from Geth that can speak to any updates or important news?
Yeah, so we made a release 10 days ago containing some denial service fixes. It was a security release, but otherwise nothing big in it. The next release will probably be contain some more fixes to which improves block processing times with up to 50%. Yeah, I don't have much else to report at this time.
Okay, thank you. Offrey or Frederick, do you guys have an update for parity?
Yes, we forked Kovan to enable WASM smart contracts. That went pretty smooth, and now there are some first contracts deployed. What else do we have? We had some issues with warp sync and added now like some kind of warp barrier to the client, so users can like configure a minimum block to warp to. That the issue is that there are many outdated snapshots out there, and it's a major annoyance that people warp to like block 4 million and then still have to synchronize through the another million blocks. Yeah, probably that's it for parity.
It's that, and that it actually doesn't sync normally. Like it forces a warp sync. So usually, like there's been a problem of you try to warp sync, it fails or can't find a pair with a snapshot, and so it reverts back to normal sync, and that'll take a week to finish. And people aren't really aware of this. So if you set this warp barrier now, it'll like actually force a warp sync update.
Cool.
Exactly.
Thanks, Parity. C++ Ethereum, Pavel?
Yeah, so I'm on the call, so I would quickly. So we separated the EVMC, which is now called the Client VM Connector API, to separate repository, and we're adding support for that to CPP Ethereum, to Hira, and to EVM JIT. And Andre is working on some network stack improvements inside the client.
Thank you. Anybody from, Mikhail from Harmony?
Yeah, there is no major updates since last release. We keep working on Casper and planning the next release now. One of the things which will definitely be included is RocksDB fine-tuning, because during last profiling of import, I noticed that reading database reads are taking about 40% of processing. So, and I'm pretty confident that it could be improved by adjusting RocksDB options and parameters. So yeah, that's all, I guess, for now.
Okay, thank you. Is anyone from Ethereum JS or the EWASM team here that can give an update on either of those projects?
Hey Hudson, this is Lane. I can speak to EWASM. Can you hear me?
Yeah, I can hear you great.
Great. I'm on a bit of an unstable internet connection. I'll keep it super brief. Not a whole lot to report. We've been doing a lot of work on EVM to WASM, which is a sort of transpiler, which would allow us to continue to run legacy EVM bytecode in kind of a WASM world. And so our current kind of task there is getting state tests running via EVM to WASM. We've got the first few passing, which is pretty exciting. We've been fixing some issues around things like endianness. And then I'll just read here. I've got an update from Everett Hildenbrandt, who's working on K EVM. He says he's been going back and forth with Yoichi about removing some tests from the VM tests to make it only test core VM infrastructure. It's a good step in the direction of separating the Ethereum specific stuff out of the EVM in the same way that the E separates the Ethereum stuff from WASM and EWASM.
Okay, great, thank you. TurboGeth, they posted an update because Alexei wasn't able to make it, working on reorg capability, and he rebased Go Ethereum as of the 2nd of April. He'll be talking about TurboGeth at EdCon, so if anyone's going to EdCon, you can see a talk on that. So that's TurboGeth. The bigger update is actually in the agenda if anyone's interested. Next we have Consensus Pegasus. Ben or Daniel, do you have any other further updates?
No news on client development at the moment, only that it's continuing apace, and hopefully relatively soon we'll be able to go public and keep you updated more closely.
Awesome, thank you. And then finally, Trinity, which I think Piper had to leave early, but he did mention there are no major updates there. Did I miss any teams or any projects or research things that need to be discussed? Okay, we're just hitting an hour and a half, so I had on the agenda that if we had time, we would get to EIP 908, reverts for clients and full nodes validating transactions, but we're just hitting the max time for the meeting, so we'll have to push that to next time. At the bottom of the agenda, or actually in the agenda, it's item number 10. If y'all could read that and get ready for next meeting, we can have some opinions on that one and kind of talk about some of the ideas. Other than that, thanks everybody for joining today. We'll see you in 2 weeks. I might not be there. I think it'll be the first core dev meeting I've missed since January 2017, but I think if I'm not there, Lane's going to be helping out. So go easy on him, and we'll see you in 2 weeks. Bye, everybody.
Thanks, Hudson.
Thank
Bye,
you.
guys. Thanks.
Bye bye.
Thank you. Bye.